So this is going to be an overview of our first unit on whole numbers. Feel free to send me an email or a message on Remind if you have any specific questions that come up that you don't understand. And what I'll try to do is answer those individually and start making kind of a collection of those answers. Anyway, let's go ahead and start with what prime numbers are. Okay, so what a prime number is it is a number that is divisible evenly only by 1 in itself. So what we do is we say it is only divisible by 1 in itself. I have an example of this coming up here in a second. An example of this would be a number like 5. Well, why? Well, what can you divide 5 by? What goes into 5? Well, you're like, well, I can divide 5 by 2. I just get a decimal. That's not what we mean. That's why I said evenly, right? So we're basically saying what whole numbers can divide into 5? Well, only 1 in 5. What whole numbers can divide into 6? See, 6 would not be prime. We have another name for that. That's called composite. A composite number is composed, there's our root word, composite, composed, or it's a number made up of other numbers. So where 5 is prime, it's only divisible by 1 in itself, a number like 6 is made up of other numbers. It could be 1 times 6, but it could also be 2 and 3. All of those divide into the 6. 7 is only divisible by 1 in itself. That would be prime. 8, well, any even number is going to be made up of other numbers. Why? Well, they're all divisible by 2. The only even number that is prime would be 2, because it's only divisible by 1 in itself. You're like, well, this is easy, right? Every even number is composite except for 2, and every odd number is prime. That's not true, because after 8 we would check 9. And why does 9 fit under composite? Well, it could be made up of 3 times 3. And so there's going to be a lot of numbers that kind of fit in these categories. We said 9 down here was there, 10 would be down here, 11 would jump back up here. Okay. So what happens is the way we kind of configure this out is we can do prime factorization or a factor tree. If you're not sure if something is prime or if it's composite, we would try to break it apart. So we try to break apart 5. I know 5 is divisible by 1. That's not very exciting. But is it divisible evenly by 2? No, 2 doesn't go in there evenly. Does 3 go in there? Does 4 go in there? No. So it's only what? 1 and 5. And that would be the prime factorization of 5. You would just say 1 times 5. If I tried to do the prime factorization of 12, 1 is not helpful, right? Because 1 goes into all of these numbers. But you would check 2. Does 2 go into 12? Yeah. That's what? 2 times 6. You could have also done 3 and 4. You could have done lots of options there. But what we do is we keep breaking it apart until all the numbers are prime. So 2 is prime. So what I would do is I would bring that down. 2 is only divisible by 1 in itself. Okay. 6, though, 6 can be broken apart. 6 is 2 times 3. So I'm fine with this. I'm actually fine with either of these. What they would probably do is they would, I'd be fine with either of these answers. What they would probably do is they would just write this as just the 5. They wouldn't write the 1 times. And this, they would take the 2 2's and write that as 2 squared times 3. So I'm okay with either of these. But just so you know, they probably will want the bottom one if you're doing the prime factorization. 80 is just a little bigger. I can start at 1, not helpful. I can start at 2. Some of you may see numbers that go into 80. You go, well, that's cool because it has a 0 at the end. And anything with a 0 at the end means it's divisible by 10. In fact, this is 8 times 10. You're like, I wouldn't have seen that. Okay, then don't do it that way. It's just divide it by 2 and keep going. Now, are we done with this? Well, the 8 is still divisible. I feel like I added a little bubble in there. I don't know why. 8 is divisible by 2 and 4. 10 is divisible by 2 and 5. Are we done? Well, this 2 is done. That is prime. The 4 is not. 4 still can be broken apart as 2 times 2. This 2 is done, bring it down. This 5 is done, bring it down. I'm okay with this answer. Or you could say, how many 2's are there? If you're not quite understanding this, we will have a section later on basic exponents that'll help understand this. But I'm fine with either of these answers if this were like a test or a quiz. What if I wanted to list all the factors? See, the prime factorization is useful if I'm wanting to figure out if something's prime, if I'm wanting to break it apart into all its little pieces. But this actually is a much more usable technique that we're going to be using a lot more when we get into the algebraic applications. So when I get to all the factors of 5, then what I do is I make a table, and I start with the lowest factor of 5, which is 1 times what? 5. After 1, I would check 2. 2 doesn't go in there evenly. After 2, I would check 3. 3 doesn't go in there evenly. If you're not sure, feel free to use some technology and do, let's see, 5 divided by 2. And you go, well, look, that doesn't go in there evenly, so it's not going to be one of our numbers here. We are at 3. 4 does not go in evenly. So this is it. This is all the factors of 5. That's also a way of verifying it's prime. All the factors of 5 would be 1, 5. That would be all factors. Okay? All the factors of 12 would be, well, start with 1, 12, 2. 2 goes into 12 6 times. 3 goes into 12 4 times. And we're done. How do we know? Well, we just went down the list, and after 3 would be 4. We already got 4. And anything bigger would have matched with anything smaller. So this is a list of all the factors of 12. We would put 1, 2, 3, 4, 6, and 12. And that's how you would list all the factors of 12. Once again, right now at the beginning, they're probably going to be focusing on factor trees more, but this t-table is actually a more useful tool that we'll be using later on. If I was to list all the factors of 80, this is going to take us a little while, but we start at the lowest factor of 80. 1 and 80. 2 goes into 80. 80 divided by 2. If I do it right, is 40. 3 doesn't go in evenly. If I try to divide 80 by 3, you end up with a decimal. It doesn't go in evenly. 4 goes in. 4 times 20. 5 goes in. Divide 80 by 5, you should get 16. 6 does not go in. You don't have to write the ones that don't go in. It's just a nice way to show. 7 does not go in. 8 goes in. That's 8 times 10. 9 does not go in. And how do I know I'm done at this point? Well, anything bigger than 9, starting at 10, would have to match with something smaller. So this would be all the factors of 80. It would be the 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. The next kind of skill that we need to focus on is our order of operations. So order of operations, hopefully you are somewhat familiar with this. Please excuse my dear Aunt Sally or PEMDAS or however you remember it. This is something you need to know, so make sure you have it in your notes, make sure you know how to use it. What frustrates me is a lot of people look at this and they go, oh, this is 6 separate steps. That's not true. There are actually 4 steps of order of operations. The first thing we look at is the P. That means we check all the parentheses. The parentheses or any grouping must be dealt with before we do any of the rest of this. With the E, we handle any exponents. The M is multiplying, the D is dividing, but this is actually our third group. is both multiplying or dividing. And we handle both. Well, how do I know what to do first? You go, well, what m came first? No. Just because it came first doesn't mean we do it first. We actually do equations. We read equations like we read a book. From left to right, whatever comes first, multiplying or dividing, we do it first. And then last, the AS is our fourth group, and that is adding and subtracting. And once again, we do that from left to right. So we go in order of operations. We start at the top, we work our way down. The confusing thing for a lot of people is that these are grouped, the MD is grouped, multiplying and dividing is grouped, the adding and subtracting is grouped. So as we go down here, any parentheses, any exponents, the little numbers up there, any multiplying or dividing? Yes, there is. Multiplying right there. I'm sorry. You're like, man, this guy's a fool. No, there's dividing right there, right? So before we get to the adding and subtracting, we divide that first. We have to bring the 24 down. Minus 12 divided by 3 is 4. And after we're done with the multiplying and dividing is when we do the adding or subtracting. And on this one there is subtracting. And so 24 minus 4 is 20. And that would be simplifying that. The next one, parentheses. There is something going on in the parentheses. We have 6 plus 11 is 17. And so we would add before we would multiply this time. Not because adding comes before multiplying, it doesn't, but because that adding was inside the parentheses. So we do that first. Going down, there are no exponents yet. Any multiplying or dividing? Well, yeah, this time there is multiplying. 9 times 17. You can feel free to do 17 times 9 on the side if you'd like. That'd be, what, 63 plus 90 is 153. Or feel free to use your technology. Okay? Some of you would have distributed this. This doesn't bother me. If you know that, that's actually not something we're doing for a while. But if you know to take that 9 and distribute it, you would get 54 plus 99, which is still 153. That doesn't bother me. That's still mathematically sound. That's not what they're going to want you to do in this section, but that is, there's nothing mathematically wrong with that. You're like, I have no idea what you just talked about. Then wait, we'll do that later. On this one, there are no parentheses. There are no exponents, but I see some multiplication. Which one do I do first? Well, they are separated, so you actually could kind of do both at the same time, but I don't recommend that. I recommend from left to right, which one comes first? 6 times 8. And bring the rest in. It's not 5.2, it's 5 times 2. Am I done? Do I start adding this? No, that's the trap. You deal with the multiplying and dividing first, so we have to finish the multiplication now. And make that 48 plus 10. And now that we're done with the multiplying, then we deal with the adding. So that 48 plus 10, how about 58? As we keep going, we have parentheses. I don't know why I put in either. How about parentheses, exponents, multiply, divide, add, subtract. Inside the parentheses, we have 5 plus 6, so we'll handle that first. 2 times 5 plus 6 would be 11, plus 7 times 3. Now, after we're done with the parentheses, no exponents here, so we do multiplying. 2 times 11 22. There is an implied multiplication there. We have those parentheses in a mathematical operation that is multiplication. I'll just bring down the rest of it. And our next step will be to finish multiplying. So 22 plus 21. And then adding that, we're looking at 43. Our next topic is going to be on exponents. For exponents, basically we have two parts. We have a base. That counts as the number we are multiplying by. We have an exponent. The exponent is the number, or the power, the number of times we multiply by the base. So literally, 3 to the 4th does not mean 3 times 4. We already have something that means 3 times 4. It's called 3 times 4. 3 to the 4th power means what? Take the base, 3. We're going to multiply by 3 how many times? The exponent. We're going to multiply by 3 4 times. This literally means 3 times itself 4 times. How would we simplify this? Well, from left to right. Well, you could use technology with this. That wouldn't hurt my feelings. But I want you to write that out and go the first 3 times 3 is 9. From left to right, 9 times 3 is 27. From left to right, 27 times 3 is 81. So that would be simplified. But for now, this is just an intro that with exponents, the base is the number we're multiplying by, the exponent, the number of times we multiply by that base. So let's write out what these mean. I'm okay if you know how to use technology, but we need to understand, what does 5 squared mean? To give you a hint, it's not 5 times 2. We have something from that. What does 5 squared mean? Multiply by that base 5 2 times. So it does not mean 5 times 2, it means 5 times 5, which is, give me a second, type it in, right? 6 to the 3rd power, or 6 cubed, does not mean 6 times 3. It means what? The base times itself 3 times. If you're using technology, that's fine. There are times that I want you to know what 6 raised to the 3rd power, and we need to be able to handle it that way. But for now, I also want you to be able to do 6 times 6 times 6 and get that same answer. Or 6 times 6 times 6, depending on your calculator. But either way, we get 216. 2/3 to the 3rd power means what? Well, 2/3 times 2/3 times 2/3. We will have a separate later on fractions, but I do want to just kind of review it real quick. So you may have already, tested out of this and already be working on fractions, so this won't hurt you for me to introduce it right now. How do we multiply fractions? We multiply fractions straight across. We multiply the numerator with the numerator. And we multiply the denominator times the denominator. Alright. So on the top, we end up with 2 times 2 times 2. Or 2 cubed. Over on the bottom, 3 times 3 times 3, or 3 cubed. 3 cubed. We should be able to do 2 times 2 times 2 in our head. If not, feel free to use the technology. 2 times 2 is 4. 4 times 2 would be about 8. We could do the same thing with 3 times 3 is 9. And 9 times 3 should be 27. And that's how we would leave that. If it needed to be simplified, we would. Once again, I'll have that as a later discussion. What does 0.3 cubed mean? We will have a later section on decimals specifically, but we should be able to write out what it means at this point. What does 0.3 squared mean, I think I may have said that wrong, 0.3 squared means 0.3 times 0.3. Now feel free to go into the rules. 0.3 times 0.3, you multiply, you move the decimal twice, that's fine. That you know that doesn't hurt my feelings. But at some point, we're not going to be doing all of this by hand. By the end of this course, and really I'm preparing you for the next course, we are going to be using technology. So we should be able to take and do 0.3 times 0.3 and get 0.09. And then we're going to go ahead and take some of the previous concepts and put them together. How do we do order of operations when I introduce exponents? Well, we still do PEMDAS. So looking at this example, parentheses, exponent, multiply, divide, add, subtract. I see no parentheses, but I see exponents. So we do that first. Two to the third is not 6, that's a lie. So don't do that. It does not mean 2 times 3. It means what again? 2 times 2 times 2. Or 2 times 2 is 4, 4 times 2 is 8. Bring the rest of it down. The only thing left is adding and subtracting. They are grouped together, so we look at all the adding and subtracting together. How do I know what to do first? From left to right. Just happens this time that we do the adding first, but that will not always be the case. We do what comes first from left to right. So from left to right, we have 9 plus 8 would be 17. And then 17 minus 5 would be 12. Next example here, PEMDAS. No parentheses again, but I see exponents. 2 to the third power is still what? Well, 8. Bring the rest of it down. Now here's where some of you are going to get in trouble. After the exponents, after we dealt with the exponents, we have multiplying and dividing. What do I do first? From left to right, people go, I see subtracting. We're not on subtracting or adding. We have to deal with the multiplying and dividing first. So looking at just multiplying and dividing, what comes first? We do not multiply the 4 and the 3 first. You will end up with some crazy decimal answer that we're not looking for at this point. We will divide first. Why? Because it comes first from left to right. So 8 divided by 4 would be 2. Bring the rest of it down. Now do I start subtracting and adding? No. We're not done with the multiplying and dividing. We multiplied the 2 and the 3 first. 9 minus 6 plus 6. Now we have the adding and subtracting. What do I do first? Well, from left to right, subtracting comes first. Do not make that 9 minus 12. That's utter nonsense. What we do is we do 9 minus 6 is 3, and then 3 plus 6 gives us a final answer of 9. So be careful with that. And the last topic that I have, just in this kind of first overview of our sections, is rounding. So for this last topic, rather than just go into the rules, I want to kind of just discuss what this means. If I'm taking 326 and I want to know where the nearest hundred is, then the idea is thinking about if I was counting by hundreds, I'm going to go ahead and think about a number line. Then I had 100, 200, 300, 400, so on and so forth. Where would 326 be? Well, it would be between 300 and 400. Well, which one would it be nearest or closest to? Well, in the middle of these two is 350. So 326 would be further to the left of that. So what is it nearest to? Which 100 is it nearest to? Is it closer to the 300 or the 400? Well, it's closer to the 300. That's the idea of rounding. What do we do with the rule? Well, we take this number, 326, and we take what they want us to round to, which this time is 100, and we underline it. And this is just a process to help us kind of see how it works. And we look at the number that's after that. So we look at the 2. If that number is a 5 or greater, we round up. Well, that number is a 2, it's not 5 or greater. If that number is between 0 and 4, we round down. That messes up with a lot of people, because when they round down, they want to change that 3 to a 2. That's utter nonsense. You're telling me that 200 is closer to 325 than 300? Well, when we round down, we're basically rounding off everything, and we are keeping the value, keep it the same. So what ends up happening is we round down, we round off everything after that 3, and it becomes a 3, 0, 0. So when we round in, that 3 doesn't really go down. We round off everything because we take off the 26, which is going down. But the nearest nearest 100 to 326 would be 300. So round down kind of messes people. So just round off might be a little better way of thinking about it. We round off the 26. The 26 goes away, and we just go down to 300. What if I did 326 to the nearest 10? I'm going to keep thinking about the number line, but I'm not going to start at 0 this time. I'm going to go ahead and start at 300, and I'm going to count by tens. 300, 310, 320, 330, 340. Where is 326? Well, it's between 320 and 330. Halfway there would be 325. Where's 326? Well, it'd be right after that, right? So where is the nearest 10? If I was counting by tens, would 326 be closer to the 320 or the 330? Well, heck, it'd be closer to the 330. Mathematically, how do we use that rule again? I take the 326. They said the nearest 10, so I underline the tens this time. The number after that tells me what to do with the 2. Well, it's 5 or greater, which means I'm going to round up. That 2, as I go up, rounds up to a. Notice still what happens after that when we round up. All the numbers after get rounded off. So that's 6. The 2 rounds up to a 3, and the 6 becomes a 0. We round it off. Any numbers that are in the big front of that stay the same. Okay? So that 3 at the beginning stays the same. Everything after what we rounded to rounds off still. Okay? Let's kick it up a notch. 5.148 to the nearest 10th. Well, where are the tenths? You do need to know your place value. I'll give you a table here at the end of this section. But the tenths come right after the whole numbers. So here's my whole number, here's my tenth. That's what I underline. Looking at the next number, 5.148. That number is between 0 and 4, which means everything will round down or round off. So it stays what? 5.1. If you prefer, I can go back to the picture. I'd like the idea of the picture, but if I took 5, 5.1, 5.2, 5.3, 5.148 would be between the 5.1 and the 5.2, slightly closer to the 5.1. That's what it means when rounding to the nearest. What is the closest tenth? Well, 5.1 is slightly closer. 5.148 to the nearest hundredth. Here's where the pictures go a little crazy, but what? 5.148. 10th hundredth would be the second digit over. The next number after that is an 8, which means that that hundredth rounds up to 5.15. This starts to get a little crazy, but call it 5.1. I'm going by hundredths this time. So 5.11, 5.12, 5.13, 5.14, 5.15, 5.16, right? I'm going up by hundredths. And 5.148 would be between these two, slightly closer. Oh, no, did I mess up? 148. Yeah, I did mess up. Let's see if I can make that dot disappear. Probably not. Hey, I did. Hey. 148 would be actually a lot closer up here, closer to the 5.15. The picture is good to kind of understand when things are a little easier, but as it gets more complicated, it becomes a little less practical. But that's what it means to the nearest. We're going to the nearest hundredth. What if I just took 5.148 to the nearest whole number? Well, the whole number this time would be the 5. The number after that is a 1. What does that mean if I count it by whole numbers? Where would 5.1 be? Well, between 5 and 6, but closer to the... See, so when you round down, that 5 doesn't become a 4. There's no way that the 4 is closer than the 5. So 5.148 would round to 5. And everything after it would round off. Or you could just write the answer as 5. Okay? Our general... Oh, we're not there. Oh, 5.148 to the nearest 10. 0, 5, 10. Oh, I'm going by 10, sorry. I'll get this right. 0, 10, 20. Well, 5.148. 5 is right in the middle. 5.1 is just after that, which means it's closest to. This one's a little weird because if I do to the nearest 10, this has nothing in the tens place. If you want to think about it, it's like there are 0 tens, right? But the number after it is a 5, which means it's between 5 and 9. We round that up. So the 0 rounds up to a 1, and everything after it rounds off. Little trick here, just kind of deep thoughts. But what's our general approach? Underline the digit we're rounding to. And second, look at the digit after. And what? If that digit is between 0 and 4, we round off. The number stays the same. Everything after becomes a 0. If the number is between 5 and 9, we round up. Just one other recap real quick before we're done with this. It's just the place value. If you need this, then I would write this down. But where I have my decimals, the box to the left of that are the ones, also referred to as the whole number. Next to the ones are the tens. I can do better than that. After the tens are the hundreds. After the hundreds, we put a comma and we put thousands, then tens of thousands, and 100,000s, and then a comma, millions, and so on and so forth. But the reason I'm doing this is because a lot of people mess up with their place value, not to the left of the decimal, but generally to the right of the decimal. And there's a pattern to this. See, here are ones, followed by tens. The pattern here is we go to the right, ones, tenths. That TH just tells me it's smaller. Tells me that 10 of these makes up one whole. Following the pattern, ones, tens, hundreds, ones, tenths, hundredths. And the pattern continues. So then we have the 1000s, the 10,000s, the 100,000s, the 1 millions, the 10 millions, the 100 millions, and this pattern continues, so on and so forth. And everything to the right of the decimal is called the same, just with what after it? Ones, tenths, hundreds, thousandths. So if you didn't need that, that's fine. That's just something I thought might help some people. But that's it. So that's a good kind of introduction. Like I said, as you're going through, if some of the questions are popping up and you feel like there's something I haven't addressed or you'd like me to address, please feel free to send those questions to me, and I'll continue to try to make some more videos to supplement this.